Welcome everyone. This is going to be a demo of how to use a layout sketch based top-down design workflow in SOLIDWORKS. We'll be creating a gearbox. To create this gearbox, we're going to use layout sketches, we're going to use configurable components, we're going to use our part templates. So feel free to follow along. I will be going quite quick, so you may need to pause the video in a few areas and to give yourself a bit more time. I just don't want to create a super long video, so hopefully this will be helpful to those who haven't used layout sketches before. We're going to be creating a simple gearbox today, just a single stage reduction, but we're going to go ahead and get started. We're going to make a new part. And this is going to be our layout sketch part. And according to our naming convention, I'm just going to save this here as 100. Let's say our gearbox is the 100 assembly. So it's going to be 100. I'm going to use L for layout. And we're going to fill the rest of the digits here. And we're going to call this gearbox layout. Okay. So with gearboxes, depending on how this gearbox is mounted to your chassis, you'll want to change the plane that you're sketching on. In our case, our gearbox is going to be sideways, so we're going to be sketching on the right plane. Normally with layout sketches, you would want to start off by sketching out your whole chassis. You want to start off by maybe sketching out your game pieces, your moving components, what you have designed around. In our case, we're not actually designing around anything, so instead we're just going to put our motor on the origin, just for the sake of the demo. On the output of the motor is going to be our motor pinion, and we're going to have a gear right here which meshes with the motor pinion. So we're ready to define everything here. So our motor here, I already know it's going to be 60 millimeters. The motor pinion, I know it's going to be 14 tooth and 20 dp, so I'm going to make that 40 divided by 20. I use the equal there just so when I am done calculating for this value, I can still double click and edit very easily. And over here, the connecting gear, this is going to be a 60 tooth 20 dp gear. And just to define this, I'm going to make this horizontal. And so that's our entire gear train. I do also want to model in the standoffs that will be used, or spacers rather. So we're going to use some 3/8 inch spacers. So I'm just going to sketch those in. I'm going to mirror this about the top plane actually, just so they're always kind of symmetric. I'm going to dimension the distance between the spacer and the gear. So I have to make this coincident to the center of the gear. I also have to make this coincident with the center of the standoff, and then I can give this a dimension of say 3/16. I usually am a bit more conservative with these measurements because of just for adjustments if you want to use a bigger gear, and also because your gear is actually slightly bigger than this. You have to take the size of your teeth into account. So I just give it a bit more space here, just so you have a bit more wiggle room in that. I'm just going to dimension, finish defining this, just so we have a fully defined sketch. And once we have that, I'm going to exit sketch, and there is a base sketch of our gearbox. Once we have a base sketch done, we are ready to move on to define everything in the third dimension. So in this case, we've defined, for example, the longitudinal position of our motor. We've also defined the vertical position of the motor, and same for everything else in this assembly, but we haven't actually defined where it is on a robot horizontally. So to do that, I'm going to make a sketch on the top plane, and I'm just going to make a rectangle to represent everything, because when you look at your plates from the top, from your motor, from your at your gears, everything just kind of looks like a rectangle. So I'm gonna just start off by making this there's going to be a plate, we're going to have a gear in the middle, we're going to have our motor pinion, we're going to have our other plate, which maybe looks a bit like this, and then our motor. We can go ahead and start defining everything. So for example, I know my motor is going to be 3 inches long. I know that this plate is going to be 1/4 inch. I can make this plate a bit thinner because it isn't mounting the motor, so that's going to be 1/8 inch. I know that my gear is going to be a 1/2 inch wide gear, and I know that my pinion is going to be 0.75. So you can pause the video here and copy these dimensions over. Okay, once you have that, we can start defining the actual position of everything. So first of all, I'm gonna say I want this motor to mount directly onto this face of the gearbox. So I'm gonna make those collinear. I know for a fact that I want this face of the pinion to line up with this face of my gear, so I'm going to make those collinear. And I can say I want a certain amount of space between my gear and the plate, so that's going to be 1/16 of an inch. And maybe I want the space between my two plates to be 1 inch. So that's kind of everything related in terms of each other. We can also work on just defining everything horizontally because it's still floating around here. Just for the sake of showing off what layout sketches can do and top-down design, I'm gonna define this and say that this interface of the support plate is gonna be 3 inches from the origin. And you'll see everything is now fully defined. Everything doesn't move left and right anymore. We did technically define the longitudinal position of all of my components in the base sketch, but I do want to reflect that in the top sketch, otherwise things could get kind of jumbled up here, and you can get confused on what actually represents what. That's not immediately obvious sometimes when you adjust things a few times. So what I'm actually going to do is I'm going to add relations that reference the base sketch. Only thing is we can't do that quite yet because you notice that for the motor I don't actually have anything here on the base sketch that I can use in my relations. So the first step is I have to exit the sketch and go back into my base sketch, and I'm just going to add points on the outsides of all of my round parts that aren't the standoff. So everything that's in the 3rd dimension sketch as well. So I'm going to do that for the gear, for the motor pinion, and for the motor. My standoffs are not in that top sketch, so I'm not going to put points on that. But once these points are in, I can edit the 3rd dimensional sketch. And I can just select the line, select the point there, and make them coincident. And I can repeat that for the bottom of the motor as well. So once I have that, this should reflect the diameter of the motor, and it does. Right there you see it's 60 millimeters. I'm going to go ahead and just do the same thing for my motor pinion here. I'm going to make all of these coincident, and then I'll repeat the same step for the gear. Just like so. So once that's done, I can exit the sketch. I don't really have to define the size of the gearbox. I find that that's a bigger hassle because I don't actually have the outline of the gearbox in my base sketch. So it's hard to really define where this gearbox starts and ends, so I just leave those hanging. But I do make sure to drag them so that they're at least close to where they would be right there. So you see it's going around the motor, going around the standoff, so that's good. Exit the sketch there. That is my layout sketch. I'm going to save this. And once I have this, I am ready to actually start creating the parts that make up my assembly. So I'm going to go ahead, I'm going to make a new part. The first part I'm going to make is the main gearbox plate. The first thing I'm going to do is I'm going to go to insert, I'm going to go to part, and I'm going to select my gearbox layout part right here. Under the transfer section, I absolutely have to make sure to check the unabsorbed sketches box, because that's what your sketches actually are. They haven't been absorbed into a feature, which is what makes them unabsorbed. So we're going to click OK, and you'll see we've just inserted our layout sketch part. So now we are ready to create the outline of our plate. So I'm going to go ahead and make that sketch on the right plane, and you can follow along here. After I place a line, I'm pressing A to get a tangent arc. So that's how you see me kind of extending the lines of tangent arcs, just like so. I'm going to make this last one tangent. I'll further define this contour just with relations. I'm going to make all of these concentric, and I'll make these two arcs equal as well. So I only have to define one of them. Make that concentric. It's slightly broken, but it'll sort itself out. I'm going to make this concentric as well, and make it equal to, actually, is this vertical? This is vertical, so that's already good. I'm going to define just some radii. This is going to be 1/16, just like so. I'm also going to include this bearing hole, which is 1.125 inches, and I'm going to include a hole for the boss of the motor so that our motor can properly align. That's going to be 0.75 inches. So once I have this is the shape of our gearbox. We are ready to extrude. So I'm going to go to the extrude boss base feature. Now we know that this is a 1/4 inch plate, but we're not just going to edit the depth of our extrusion, because we want to make everything in relation to the layout sketch, so that if we ever need to change geometry, we can do so in the layout sketch. So we're going to extrude from a certain vertex. So I'm going to go from this vertex up to this vertex. And that's going to define A, the thickness of our plate, and B, the location of our plate. Because now this plate is going to be the correct distance away from the origin. So I'm going to assign the material. And the last thing I need to do is just put in the holes. So I'm going to have number 10 clearance holes for these two standoffs. And then also to mount the motor. So I'm going to sketch this, I'm going to sketch a 2-inch bolt circle here. Make that for construction. I'm going to place my points just around the circle. I'm going to say OK. So there's my part. It looks good. Once we're done with parts, it's very important that we hide the sketches. Otherwise, they're going to start overlapping in the assembly, and they can get really messy that way. So I'm going to hide the sketches there. I'm going to save this according to our naming convention. So there's a part, so it has a P. There's the first part, and it's the gearbox main plate. Just like so. I'm going to repeat a similar process to create our second plate. So I'm going to go to insert part, and this is going to still be the layout. So we've inserted our layout sketch. We can start sketching out our second plate. So we're going to go to the right plane. We're going to create a sketch very similarly to the first. define it in the same kind of way. Again, this is a 1/4 inch radius. This is going to be an 1/8 inch from the gear there, and this is going to be just a 1/16 away from the edge of the motor. Am I missing a tangent? There we go. I'm going to have the same bearing hole here, but I'm going to have a slightly bigger hole here, which just accounts for the pinion. So really this is identical to the last sketch that we had, except that this hole has a slightly different diameter. So that's going to be a 0.9 inch instead. And we're going to extrude this. Again, we're going to extrude this according to our layout sketch. So we're going to go from this vertex up to this vertex. So that's what's defining the thickness of the plate, is the actual layout sketch. Again, I'll set the material, and I'm going to use Hole Wizard just to place our number 10 clearance holes. Go, so I'm going to say OK. Again, I need to remember to hide my layout sketch, and I'm good to save this as a part. Okay. I'll move on to our next part, which is actually going to be the hex shaft, the output shaft. We're going to use rounded hex, so we can use the part template. With part templates, you already have geometry here. You can still insert your part. Here's your layout sketch. I'm going to say insert, and yes. The first thing that I'm going to note is that we don't actually have anything to define the length of the hex shaft, so I'm going to quickly add that to my layout sketch. So I'm going to go back to my layout, and on the top, on the third dimension sketch, I'm going to edit this, and I'm just going to add a center line here, which is going to represent the hex shaft. So the center line has to be coincident with where the shaft passes through, and I can also just define just kind of how far it sticks out. So I'm going to say it sticks out just 1/16 of an inch here, just to account for the flange of the bearing, and I'm going to say I'm using a 4-inch hex shaft, just like so. I can exit the sketch. So now when I go back to here, I can rebuild, and now I have this line here that I can use for my length extrusion. First thing is I'm going to edit the sketch, and I'm just going to relocate the profile. But you'll notice that when I go to edit the sketch, my layout sketch disappears. This is a quick fix. That's just because the layout sketch was inserted after the profile. So all I have to do is I have to drag the layout sketch to the top. Then when I edit the profile, my layout sketch is still there, so I can just redefine the position of the hex. So I can exit sketch there, and then I'm free to change the extrusion to go from this vertex here up to this vertex out here. And so the length of the shaft is defined, the location of the shaft is defined. That's this part done. I'm going to hide the layout sketches there, save this, and give it a good name. Gearbox output shaft. And then the last part that I have to make is the spacers, for which I'm going to use round tube, specifically 3/8 round tube, so I can actually go ahead and just modify the profile to make it 3/8 round tube. Exit sketch. Again, I'm going to insert a part. I'm going to insert the layout sketch, just like so. I need to drag the layout sketch all the way to the top so that when I edit the profile, I can now use a relation to just put that in place, and then I can change my extrude to go from this vertex up to this vertex. So the location and length of my round tube is defined. I'm going to hide the layout sketch again. I'm going to save this part really quickly. Just like so. So now that I have all my parts, I'm ready to create an assembly. So I'm going to make a new assembly. And the first thing that I insert into any assembly is I insert the layout sketch. And I'm not just going to click out here to place the layout sketch. No. Because that places the layout sketch in just a random location, which I don't want. What I want is I'm going to click OK, and what that does is the origin of the component I'm placing, which is highlighted there, always matches the origin of my assembly. And this is important because when I go ahead and insert my main plate, I can just click OK, and that's already snapped to the right place, and that's already fixed. I can do the same thing for my support plate. I'll do the same thing for my output shaft, and I'll do the same thing for my spacer, and you'll see that everything is already in the right place. And according to my layout sketch. If I ever wanted to change anything, I can do so by changing my layout sketch. So for example, if I say I wanted to change this to a 3-inch output shaft, I can do that. And then when I go back to my assembly, say OK, you'll see that the output shaft length there changes automatically and the position is still correct. So next thing I have to do is I just have to make a few copies of the spacer. Unfortunately, I can't really do that without mates because there's so many of them all over the place. So I'm just going to make a few copies there. I can hold Control and drag apart to make a copy. And then I'm just going to mate them in place with a few concentrics. Just like so. Now I have to mate these in their horizontal direction. So what I'm actually going to do is I'm going to mate, I'm going to use a multi-mate, and I'm just going to use the right plane of the assembly, and I'm going to mate the right plane of all of these individual standoffs, because the right planes, remember, they're already in the right place. So I just have to select the right plane of all my standoffs, which is 1, 2, 3, and 4. As long as I mate all of these to the right plane of the assembly, they will be in the right place, as you can see. So really the last thing I need to do is put in my off-the-shelf components. So I'm going to grab my motor, which is a Kraken. I'm going to grab the pinion for that motor, so 20 DP pinions. I'm going to grab the pinion there. And I'm also going to insert a 20 DP gear, and it will be the 60 tooth. So configurations, I'm going to choose 60 tooth and say OK. And there we go. So now we can work on mating all these components in place. When I'm doing mates, I still like to mate everything to the layout sketch because the layout sketch is the most robust. If I ever break anything, so the gearbox plate, one of the faces may go away, maybe some of the holes, they might disappear. It doesn't matter to me because the layout sketch will still be there, so my mates won't break. So I'm gonna make that concentric there. I'm gonna make this coincident to, I have a short line in here. In order to access that, I'm gonna right click and go select other, and then I can select that line there. I'm gonna make it coincident with the front face of the motor. I'm gonna grab the pinion, make it concentric with the circle and the layout sketch. I'll do the same thing with my gear. For the gears, you should try to use the yellow mating circle because this circle is always there, doesn't break, so your mates are always going to be there. I'm just going to repeat a similar thing here. I'm going to grab this face of the pinion and make it coincident with that line in my sketch, and do the same thing for this gear. So now all of those are almost fully defined. I just need to fix the rotation of this motor. The only way to do that is to actually use one of these mounting holes and make it concentric with one of the mounting holes of my plate there. So that's fully defined. And so the last thing I need to bring in are my two bearings. So that's going to be bearings folder, like configurable bearings. I'll use the rounded hex bearings. That's what these are for. And again, to mate these, I'm going to mate these to my layout sketch. I can then also make this coincident there to the layout sketch, just like so. And so all that is fully defined. Whenever I make a change to the layout sketch, everything will update accordingly. So this just makes the iterative process much, much faster. If you want to get rid of these ugly sketches, all you have to do is click the little eye icon up top, and that toggles that. So that's a quick run through on how to use layout sketches. Hope you're able to follow along. And yeah.